Hey, what's up guys? It's Pedro here from noobcoder.com. And in this tutorial, we're going to be talking about removing the first node within our doubly linked list. So to get started, we actually have three test cases. If the list is empty, if the list only has one node, and if the list has more than one node. In case one, where the list is empty, we're not going to do anything. So we could just skip that case. Case 2, which is what we have on our screen right now, is what happens if the list only contains one node. Well, we have header pointing to this node and tail pointing to this node because this is the only node within our list. So in order to check if there's only one node within the list, we can say if the size is equal to 1, that means there's only one node within the list. Or we could check to see if header arrow next is equal to null. If header arrow next is null, that means there's also one node within the list. So the first step, if header arrow next is null or the size is equal to 1, is to delete the node that header is pointing to. Once we delete the node, we have to set header to be equal to null and tail equal to null. And the last step, once we do that, is to decrement the size. So now that we know how to handle this when we only have one node within our list, let's move on to case 3. What happens when we have more than one node within our linked list? Alright, so from here, you can see that we have our list and that it has 3 nodes within our list. And we want to remove the first node. So the obvious place to look is our header pointer, because header is always pointing to the first node within our list. Now, the first step that we want to do is advance the header pointer. Header is going to point to header arrow next. That will get me here because header has access to this node and we're just making header point to what this next pointer is pointing to, which is this node here. Now, the next step after that is to delete the previous first node. So who has a pointer to this node? Well, header arrow POEV points to the previous first node. So I could delete the node that way. Now, once that we successfully deleted the previous first node, it's time to set header arrow POEV equal to null. And since we successfully deleted the node, last step is to decrement the size. Alright, so now let's actually take a look at how we could write this in code. Alright, so from here, you can see that we have our remove first method. It's void, so we're not returning anything. And we have no parameters here. So the first case, check if there's only one node within the list. So that's pretty simplistic. We could check to see whether the size is equal to 1. Or we could check to see if header arrow next is equal to null. So I'm just going to say, well, header arrow next equals to null, execute this code. So what do we want to do in this situation? Well, we need to delete the node that header is pointing to, since this is the only node within the list. And we need to set header equal to null and our tail to equal to null. So we're basically resetting our linked list. So now the second case, check if more than one node within the list. So I can use an else if statement. So I could say something like this. If the header does not equal to null. And the reason why I'm using this test case is because there's actually 3 test cases. The first test case is what happens if the list is empty. By setting it header not equal to null, that effectively means that I do not have to worry about what happens when the list is empty. So this is effectively checking if we have more than one node within our list. So now I'm just going to come down here. The first step, advance header to the next node. So I'm just going to say header is going to be advanced to header arrow next. Now we need to delete the previous first node. Remember, header is always pointing to the first node. We advanced it to the next node. Now we need to delete the previous first node. How do we do that? Well, I could say delete header arrow POEV because arrow POEV is going to point to the previous last node. So I could just delete it like this. Now the last step is to set header arrow POEV equal to null. And now I'm just going to decrement the size here. because we successfully removed a node. And I'm going to decrement the size here. All right, so I'm just going to save this. We're going to go down to our main method. I already have this written out. So we append 3 things, print it out, remove the first node, and reprint it just to see if the first node is removed. So let's bring up the console. And now let's execute our linked list. And you can see we get the printout of 1, 2, 3. That's the first 2 string. We call the remove first method, and you can see that it successfully removes the first node within our linked list. So that pretty much wraps it up for our remove first method for our doubly linked list.